In today's video, we're going to be completely debunking Gödel's incompleteness theorem with 4 mathematicians fact-checking this video. 2 of them are from Berkeley, and they are specifically logicians as well, so they're ultra knowledgeable on this subject. One of them has chosen to remain anonymous, and one of them has chosen to go public, so we can share all the emails and everything from that one, and you guys can fact-check if I'm actually talking to mathematicians or just making up a bunch of crap, okay? So the other 2 are not specifically logicians. Now, in order to address the theorem, we have to have a reasonable summary of the theorem. 3 out of 4 of the mathematicians have approved of my summary, and the one who didn't agree, he does not contest point number 3. And point number 3 is the only point we're going to be zeroing in on and looking at, okay? So, point number 1 is that Godel reasons logic statements can be encoded into mathematical language. Point number 2 is Godel creates a system of translation and assigns a Godel number to each statement. I think this is where mathematicians overall will disagree the most, because that's an extreme oversimplification of what's going on. But again, we're not really contesting that point. Okay, I don't have a problem with number 2, so let's get on to number 3. Number 3 is Godel creates Godel number G5, which states that G5 is unprovable. This creates a paradox. If G5 is provable, then it's unprovable, and if it's unprovable, then it's provable. Point number 4 is therefore Godel concludes if a mathematical system contains G5, then it has a valid contradiction, and if it doesn't, then it is incomplete. And this is the gist of the incompleteness theorem. All right, so we're going to be zeroing in on the third part of the theorem here, which is this statement is unprovable, and we're talking about this statement itself. So it's kind of like a combination of the Bertrand-Russell paradox and the liar's paradox. And this is why I think a lot of people get confused. Some mathematicians say this is closer to the Bertrand-Russell. Some say it's closer to liars. I think it's kind of a hybrid. So we need kind of a unique solution to resolve this. And that's what we're going to get into here. Now, this is a library here. And this is an analogy given by a logician from University of Chicago. It's a really good analogy because we get to look at things physically. We're going to look at physical books, which are much easier to visualize than an abstract statement like this. So, we have books that do contain their title inside the contents, and we have books that do not contain their title inside the contents. So what does that mean? You know, every book in our library is organized into one of these 2 sections. Now we get this book called Finding Nemo, and on page 271, sentence 4, it says Finding Nemo. So clearly, this book contains the title somewhere inside the contents, so which section does it go into? Well, you can think about it for a second. The answer is this section, right? Because it contains a title and the contents. And now we introduce the Godel book from hell. And maybe it's not from hell. Godel was not such an evil guy, but maybe his book is. Maybe his book is evil, okay? Godel didn't like the Nazis, so I think Godel's probably a good character. But this is a list of all books that do not contain the title of the book inside the contents. So the contents of this book, when we flip through this book, it's simply a list of the title of every book inside this section. So which section does the Godel book go into? Well, right now it doesn't contain this title inside the contents, so we have to put it into this section. But the effect of doing that is now we have to list this title inside the content. If that doesn't make too much sense, just think about it for a while. Here's a picture. Look at it. Think about it for a bit, right? The effect of putting it in this section is that now the title goes into the contents. And the effect of putting the title into the contents is that it is no longer a member of this section, right? It no longer can belong to this category because this book does contain its title inside the contents. So as soon as we write the title inside the contents, it loses membership in this section and it gains membership in this section. The effect of putting it in this section is now we have to erase the title from the contents, right? Because this is a book which is a list of every title in this section, and it's no longer inside this section, so we have to erase the title from the contents. And the effect of that is we're kind of back at the stage 1, all right? All right, so this is just a list of all the events that we just did. This is a summary of what we just went through, listed in 5 events. And Veritasium is arguing that there's a contradiction because The book is in both categories simultaneously. The logician and I investigated the possibility that it's in neither. And so let's see if this is true. Now first I want to look at this light bulb here. Okay, this is the light bulb paradox. Actually, this is not the light bulb paradox. But we have a light bulb here and it's on, it's off, it's on, off, and it's flickering between on and off repeatedly. So the question is this light bulb on or is it off? Well, the answer is it's both, right? And that's not a contradiction because it's simply on and off at different times, okay? You can have different states if it's at a different time. It's only a contradiction if it's simultaneous. Now, when we look at event 3 here, as soon as we write the title into the book, it instantly loses membership of category B and it gains membership of category A, okay? So it does not ever belong to both category B and A. So, and the same thing is going to happen in step 4 and 5. As soon as we erase the title, it's going to lose membership in category A and gain membership in category B. So it's definitely not in both categories simultaneously. Now the logician says it could be in neither category. Okay, so let's investigate this possibility that it's in neither section. And this is going to bring us to the light bulb paradox. We have our little light bulb here. And, you know, it goes on and off. It's flickering on and off. And we're speeding up the flickering more and more and more and more until there's 0 seconds of time between on and off. So now the question is the light bulb on or off? Well, there's a simple answer to that, which is that this is an impossibility. Okay, this is a logic error. We are imagining change without time, when time is change itself. So what that means is in order for something to change, time has to occur because that's what time is. Time is change. So if there's no time, then everything is frozen. That's kind of a good way to imagine it. You remember from all these like kids movies, when you stop time, when your clock isn't moving, everything is frozen. Everything in your universe is frozen, including your clock. So if everything is frozen and nothing can change, then how can a light bulb move from on to off? That's an impossibility. In this case, we certainly do have a chronology of events. You know, event 1 has the effect of number 2. Event number 2 has the effect of number 3. We can't discuss the effects of time if we removed time from our analysis. So in this case, let's just go over Godel's theorem again. We have point number 3, which is that this statement is unprovable. And this is going to be the same resolution as to our bookcase or library problem, okay? The provability of the statement causes it to become unprovable, and the unprovability causes it to become provable. We have a clear cause and effect taking place, just like in this book analogy. No change can occur without time, and we're imagining a whole bunch of changes without time. All right, this is where I got up to with 3 out of 4 of the mathematicians and 1 of the logicians. And they didn't have any problem with my explanation of point number 3. They didn't have a problem with the library analogy. They didn't have any sort of problem with this idea that things need to be simultaneously in mutually exclusive categories to have a valid contradiction. And they don't have a problem with the light bulb paradox and the idea that time is necessary for change. So where we hit the crossroads and our discussions kind of end is they say, well, you know, the abstract world has different rules. It's this ideal world where things don't have to operate like in reality. Like in reality, your brain needs time to process logic sequences, right? Electrons have to flow between each thought and each event. And on a computer clock, you know, your computer processor has a clock, same thing. It takes time for the computer to run each event. So in the abstract world, though, you know, we're imagining these ideals where you don't have these lags like on a computer or a brain. And I would address that by saying when we have causes and effects, this is chronology. And that's where I guess I would end the discussion and debate. And one of the logicians we're still going back and forth with, and he'll probably have some kind of response to that. I want to say, you know, I'm super, super happy with Leo from Berkeley, okay? This guy is an excellent, excellent, excellent professor. I approached him and I said, I'm a skeptic of this whole Godel theorem. I don't believe in this. I said, well, then you probably don't want to help my investigation, right? Because that's usually my experience. If someone has an opposing view, they usually don't want to help my investigation. And he said, this is precisely why I do want to help your investigation, okay? That's something that's becoming a very rare attitude in the intellectual world. In the intellectual world, it's becoming so much of a contest who can prove their intellectual superiority. If you like this video, please share, subscribe, blah, blah, blah. And I'll have some more videos coming up. Next one is going to be on non-Euclidean geometry. We're going to be investigating some of this stuff and whether it makes any sense or not.